In this example, we're asked to determine the points of intersection of the function f at x, 5x squared minus 2x plus 3, and the function g at x, which is negative x plus 10. The function f at x is a parabola. The parabola opens up because the a value is positive, so I have something that looks like this. And then the function g at x is a linear function. It's in the slope-intercept form, and it has a negative slope because of this coefficient that's negative. So I have a line that's going down to the right. And from this little sketch, I can see that there will be 2 points of intersection. 2 points of intersection. And I need to find those points. This is actually a linear quadratic system of equations. In grade 9, you learned how to solve a linear system of equations where both equations were linear. And you solve them algebraically in grade 10 using the method of substitution and elimination. We can use substitution here as well. So if I let the first function f at x be represented by equation 1, so y is equal to 5x squared minus 2x plus 3. And I let function g at x be my second equation. I can take this expression for y from my first equation and sub it into y in my second equation. So subbing 1 into 2, I end up with 5x squared minus 2x plus 3 is equal to negative x plus 10. This, if I look at it, is a quadratic equation that I need to solve. And to solve a quadratic equation, I need to make sure that I make one side equal to 0. So I'm going to add x and subtract 10 from both sides. So doing that, I get this next line. And then combining my like terms, I end up with 5x squared minus x minus 7 is equal to 0. Now this equation is not factorable, so I'm going to solve it using the quadratic formula. Okay, so a is 5, b is negative 1, and c is negative 7 based on the values that I see here. Okay, subbing those values into the quadratic relation or quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a, I end up with negative times a negative 1 plus minus the square root of negative 1 squared minus 4 times 5 times negative 7 all over 2 times 5. Evaluating 1 plus, and then this ends up being 20.25, sorry. 1 minus 4 times 5 times negative 7, I get 141 all over 10. And I'm not going to use exact values in this case. I'm going to use approximate values when I evaluate, so I can leave them as decimals, rounded to 2 decimal places. I get 1.29 for my first value of x, and I get negative 1.09 for my second value of x. Okay, so this point up top is the one that's going to be furthest to the left, and it's going to have a negative x value, and this point here at the bottom will have a positive value of x. Now I just have to find the corresponding y values of these points. If I know x and I have the equation, I can find the corresponding y values. it doesn't matter which of these two equations you use, but it's easier to evaluate the linear equation than it is the quadratic one. So I'm going to sub those answers of x that I got into this linear equation. So when x is equal to 1.29, I would end up with negative 1.29 plus 10, which gives me an answer of 8.71. And when I sub in negative 1.09 for x, I end up with 11.09, okay? So when x is equal to 1.29, the y coordinate is going to be 8.71, sorry. And when x is equal to negative 1.09, the y coordinate is 11.09. So those are the 2 points of intersection right here, okay? And we can write a therefore statement, therefore the points of intersection are 1.29 and 8.71 and negative 1.09 and 11.09. Okay, let's look at word problem. Okay, so the word problem that we're going to do is on page 197. And it says, Justin is skeet shooting. So a skeet is a disc that you launch into the air, and then someone takes a rifle and aims the rifle at the disc for target practice. It says the height of the skeet is modeled by the function h of t, which is equal to negative 5t squared plus 32t plus 2, where h of t is the height in meters, t seconds after the skeet is released. The path of Justin's bullet is modeled by the function g of t, which is equal to 31.5t plus 1, with the same units. How long will it take for the bullet to hit the skeet, and how high off the ground will the skeet be when it is hit? Okay. So I'm going to write the two equations that models the height of both the skeet and the bullet. And the two equations are h of t, which is equal to negative 5t squared plus 32t plus 2. That'll be my first equation. And then the second equation is g of t, which is equal to 31.5t plus 1. Okay, both of these equations represent the height. So the height of the bullet and the height of the skeet will be the same when the bullet reaches the skeet. Okay, and remember, this is just function notation. They both just represent y, or the height. Okay, so I'm going to sub one of these equations into the other. Another way to look at it, you're setting the heights equal to each other. So negative 5t squared plus 32t plus 2 would equal to 31.5t plus 1. Next step is to make one side equal to 0. And then you would need to collect the like terms. So negative 5t squared plus 0.5t plus 1 will equal to 0. Okay, next I'm going to use the quadratic formula. So I have to identify the values of a, b, and c. A in this case is negative 5, b is 0.5, and c is 1. Now I can use the quadratic formula to solve for time. Subbing in the values, I get negative 0.5 plus or minus square root of 0.5 squared minus 4 times negative 5 times 1. All of it divided by 2 times negative 5. Now simplifying. part under the square root is going to end up being 20.25. And 2 times negative 5 is negative 10. Okay, and now we're going to use our calculators to determine the approximate values for time. It makes sense to use approximate values for time, not exact. So negative 0.5 plus the square root 20.25 divided by negative 10. You get negative 0.4 as one of the answers. And the other answer, let's see, negative 0.5 plus the square, minus the square root, 20.25 divided by negative 10. I got 0.5 as the other answer, okay? So these are the times when the bullet will reach the skeet. Now, only one of these times makes sense in the context of this problem. Obviously, it can't be negative. Time can't be negative. So the bullet reaches the skeet at 0.5 seconds. Now, at what height does it reach the skeet? So now I take the time and I plug it into either of these equations for height. I'm going to use the linear one because, again, the linear one's easier to evaluate than the quadratic one. So in place of t, I'm just going to sub in 0.5. So I have 31.5 times 0.5 plus 1, giving me a height of 16.75. So therefore, the bullet hits the skeet at 0.5 seconds at a height of 16.75 meters.